Question number 5, practice test number 3. We're asked to find the standardized test statistic t for a sample with n equals 15, x bar, which is the sample mean of 4.9, s, which is a sample standard deviation, 0.8, and alpha equals 0.05. Now look where the test statistic is a t, not a z, a t. And we're given that the null hypothesis is the less than or equal to. So let's look at how we need to set this up, because we could very easily get it backwards. So we come here, we're going to back it up. We're going to go back to inference. We're going to set up a hypothesis test. We have a sample mean, a single sample mean. So we're doing tests. We're going to do one mean, and we're going to do the t-test because that's what they're asking for. Oops, t. Right? Null hypothesis we're given is that it's less than or equal to 4.6. That's what, but our option is only to put in that the u is equal to 4.6. That's okay. So let's go ahead and enter that. 4.6. And now in the alternative hypothesis, this is where we're going to choose the complement of what is the null hypothesis. So since the null hypothesis is less than or equal, the alternative is going to be greater than. This is going to make it a right-tailed test. Okay, so that's why all these t-values are positive. It's on the right side of things. If you do it the other way, well, you would get a negative value because you'd be looking for a left-tailed test, and it would be kind of strange anyway. You get some really different values, which I'll come back and I'll show you if you're interested in seeing, because sometimes it's good to see what when you do something backwards, what does it look like? Okay, so we input our statistics. We've got our sample mean as 4.9. So again, you've got to get all your values in the right place. Sample standard deviation S 0.8. Sample size is n, that's the 15. And the significance level we're given is 0.05, which is our default, so we don't have to change it. Go to the next, and there's our t statistics, 1.452, and that's right here, that's D. Okay, it's got a p-value of 8, so at the alpha level, we would not reject this. That's not what it's asking, but definitely this would not get rejected. But let me just show you what this looks like, because it's a right-tailed test, right? It's in the right side, out of the rejection region. What if we had set this up incorrectly? Again, it's always good to know what happens when you make mistakes. So you could look because this is an easy mistake to make. Say, okay, less than, so maybe I should make this less than, right? Now this is going to give us an incorrect value, but watch what happens here. Same statistics, so that's all the same. Our t statistic is the same. We probably would have got this right for this, but had the question been asking to reject or not reject, okay, well, you don't reject this one either. But notice it's over here, it's a left-tailed test. Our t is in the same place, so in a way, this question, we're saved from it if we didn't set it up correctly. It's not dependent upon that. But this kind of looks like, if you see something like this in a hypothesis test, you're going to say, wait, that's probably set up the wrong way. There's too much probability of not passing. Anyway, that's just there. That's how we find a t statistic.